Now this is an interesting question involving complex numbers and parabola. It says, let Z be a complex number of maximum amplitude satisfying mod of Z minus 3 is equal to real part of Z. Then we need to find the value of mod Z minus 3. So first we'll simplify this equation. So what I'll do is I'll let Z as x plus iota y. So then we can write x minus 3 plus iota y is equal to real part of z, which is x. So we'll find its magnitude and we'll square it. So we'll write x minus 3 square plus y square is equal to x square. So we'll get x square plus 9 minus 6x plus y square is equal to x square, which will get cancelled. So we'll write y square equals 6x minus 9, or y square is 6 and then x minus 3 by 2. If we'll compare it with the standard parabola, then it will be y square equals 4a capital X. Now in this case, value of a is simply 3 by 2. So we have this parabola whose vertex is at 3 by 2 comma 0. So we'll draw this parabola. Now on this parabola, we need a point Z having maximum amplitude. We know that amplitude is nothing but angle that a point makes with positive real axis. So if we look at these points, then we know that this angle, it is increasing. Then we'll have one point where this argument will be maximum. So this argument will be maximum at a point P at which tangent drawn will pass through origin. So we'll need to find coordinate of this point P. So once we have equation of this parabola, we can write equation of tangent as y equals m. Now in place of x, we can write x minus 3 by 2 and then plus a by m. Now a in this case is 3, so it will be 3 by 2m. We need that tangent which passes through origin. So we'll put x and y as 0. So we'll put x and y as 0. We'll get 0 equals minus 3m by 2 plus 3 by 2m. So from here we'll get the value of m as plus or minus 1. Now since we need z of maximum amplitude, we'll take m as plus 1. So for this z, value of m is plus 1. Now once we have this slope, we can write this point of contact. So this point of contact will be x equals a by m square. Now x in this case is x minus 3 by 2 and it should be equal to a by m square and then y equals 2a by m. Now we'll put the value of a and m. Now a is 3 by 2 and m is 1. So we'll get x as 3 and y as 3. So this point P, its coordinate will be 3 comma 3 and this z is 3 plus 3 iota. Now we need to find the value of mod z minus 3. So mod z minus 3, it will simply be mod of 3 iota and mod of 3 iota is 3. So answer to this question is 3. Now here the question is, let z be a complex number satisfying this equation, which is mod of z minus 2 is equal to real part of z. Then we need to find minimum value of mod z minus 4. Now we are given that mod of z minus 2 is equal to real part of z. So we'll take z as x plus iota y. Now we can write this as mod of x minus 2 plus iota y, and real part of z, it is simply x. So it will be under root of x minus 2 square plus y square equals x. So we can write x square plus 4 minus 4x plus y square equals x square. So we write this equation as y square equals 4 x minus 1. So basically z lies on this parabola whose focus is at 1, 0. So we'll draw this parabola. It says we'll need to find minimum value of mod z minus 4. So in complex numbers, we know that modulus is basically distance between 2 points. So one of the point is z, which lies on this parabola, and another point is 4, which lies on axis of this parabola. So we'll need to find the minimum value of this distance between a point on parabola and this fixed point. Now we have already studied that minimum distance will occur along a normal which will pass through this point. So what we'll do is, for this parabola, we'll write equation of normal. So for this parabola, equation of normal will be y equals m. Now in place of x, we'll write x minus 1 minus am cube. A in this case is 1. So it'll be m cube minus 2m. We need that normal which passes through this point 4, 0. So we'll put y as 0 and x as 4. So it'll be 0. And then 3m minus m cube minus 2m. So it'll be m cube minus m equals to 0. We'll get 3 values of m. Either m is 0 or m is 1 or m is minus 1. Now 3 normals can be drawn from this point 4, 0. We need to find shortest distance from this parabola. So we'll write foot of all the 3 normals. So we know that foot of normals is given by am square minus 2am for a parabola which is y square equals 4ax. But we have a parabola which is y square equals 4x minus 1. So in this case, foot of normal will be given by 1 plus am square minus 2am. Now for this parabola, value of a is 1. So now we'll start putting the value of a and we'll start putting in the value of m. So we'll take m as 0. We'll get this point as, say, a, and it will be simply 1, 0. If we'll put m as 1, then we'll get this point, say, b. So a is 1 and m is 1. So it will be 2, minus 2. So b is 2, minus 2. And then we'll find this point which is c when the value of m is minus 1. So we'll put m as minus 1. We'll get this point c as 2, 2. So this point, it will be 2, 2. Now we'll find all these 3 distances and then we'll see which is the minimum distance, and there will be the minimum value of mod z minus 4. So we'll find this AP. So this AP is simply 4 minus 1 and that is 3. And from symmetry we can say that BP must be equal to CP, and this value, it will be under root of 2 square plus 2 square, and that should be 2 root 2. So the minimum value of mod z minus 4 will be simply 2 root 2, and that is the answer to this question. Now this third question is, we are given a set which is sigma, which is set of all complex numbers x plus iota y such that mod y is less than or equal to 1. And then we are given this function which is fz, and that is z square plus 2. Now it says, draw a sketch of f sigma which is fz for all z belongs to sigma. So that means for all the complex numbers z present in this set, we need to draw the sketch of fz. Now first we'll look at input values. Now this sigma, it contains all the values of x and y such that mod y is less than equal to 1. So when mod y is less than equal to 1, it means value of y should lie between minus 1 and plus 1. So its domain space is within these two lines, which are y equals 1 and y equals minus 1. So we are talking about all the points in this shaded region. Now we'll put the points from domain in this function, then it will transform into an output space. Suppose u plus iota v. So we'll write this fz as sum u plus iota v, and it is z square. Z is x plus iota y whole square plus 2. So we'll write this as u plus iota v, and it'll be x square minus y square plus 2 xy iota. Now we need to draw sketch of u and v. Now comparing real and imaginary part, we can write u as x square minus y square plus 2, and we'll write v as 2xy. Now the condition given in the question is this mod of y is less than or equal to 1. Now what we'll do is we'll begin with the boundary cases. The boundary cases which are when the value of y is 1, when the value of y is minus 1, also when the value of y is 0. So when the value of y is 1, in that case u will be x square plus 1, and v, it will be 2x. So we can write this x as v by 2. So we'll write this as v square by 4 plus 1. So we'll get this parabola, which is v square equals 4u minus 1. So we'll take this boundary condition when the value of y is 1. We'll end up getting this parabola, which is 4u minus 1. Now we'll take y as minus 1. If we'll take y as minus 1, again we'll get u as x square plus 1, and v is minus 2x. Again we'll replace x with minus v by 2. So we'll get u equals v square by 4 plus 1. So again we'll get v square equals 4u minus 1. So that is for both the boundary values 1 and minus 1, we are getting the same parabola, which is v square equals 4u minus 1. Now if we'll put y as 0, in that case we'll get u as x square plus 2 and v as 0. In that case we'll get a ray lying on x-axis, and which is greater than or equal to 2. Its y coordinate will be 0. Now what we'll do is we'll plot these three sketches. Now this is u and this is v. Now this is y square equals 4ax. So it represents a parabola opening rightwards and shifted 1 units to the right. So we can draw this parabola as v square equals 4 into u minus 1. Now second one, it's again the same parabola. And this third one is u equals x square plus 2. So in this case, u will be greater than or equal to 2 and v is 0. So I'll represent this ray starting from 2 and going towards infinity. So this is the sketch of boundary values. Now we need to find this complete region. Now we know that this u is x square minus y square plus 2 and v is 2xy. So we'll square this second equation. We'll get v square equals 4x square y square. Now in the question it says mod of y is less than equal to 1, which simply means y square is less than equal to 1. So we can write v square is less than or equal to 4x square. Now from this first equation we can write y square, it is x square plus 2 minus u, and again it is less than or equal to 1. So from here we'll write x square is less than or equal to u minus 1. So now we have two inequality relationships, which is v square is less than equal to 4x square and x square is less than u minus 1. So from these two we'll get this condition, which is v square is less than or equal to 4 u minus 1. So that means for all the points in this input space, we are getting a condition where v square should be less than or equal to 4u minus 1. So if we'll take any point, say origin, if we'll put v as 0 and u as 0, we'll get 0 is less than or equal to minus 4, which is incorrect. So that means we are talking about region other than origin. So the sketch of output space is this parabola and points lying inside of this parabola. And that is the answer to this question.